Yeah. All right. Okay. Look, we're online. We're connected. We're good. Hopefully. Welcome back to a new year, 2023. The stream is ongoing and continuing on. It's good to see you once again. Hopefully the levels are good. Chat, so you'll just have to let me know how we're doing here. Okay. I think we're going to continue on working on our Asteroids clone. We got it here. This is our thing. Apparently it's not responding to my input here for some reason. Maybe something funky's going on. Oh no. Okay. Well, I gotta figure out what's happening here, but this is our Asteroids clone, and it's not working. It was working, but now it's not. And I don't know why. So let's look at that, see what's going on. Hope you had a good holiday. I know I did. Just gonna go to projects and asteroids. I had pseudo random stuff. Oh, maybe that's the problem. Okay, we'll see. Maybe I left the code in a bad state. Let's. Oh, I'm not in the project directory there. Build fast file watch. Ah, yes, we did. Okay, that's probably something to do with it. So as you may or may not recall, unless this is your first time joining or you missed the last few streams or whatever, it was a busy month last month for a lot of folks. We were kind of working on adding asteroids to the game of Asteroids. And we're experimenting with this idea of like a pseudo randomish generator. So not like we're just kind of like seeding a bunch of random numbers that we're going to just use during the game into this thing called a pseudo random. And then we'll just use some functions when we want to generate a new asteroid to get the next however many points we want on a asteroid. The next 6. So it'll be somewhat random per game, but not like super ultimate random every time we go to generate an asteroid, which is a pretty good middle ground. I think it'll be good enough for the game, hopefully, to look kind of nice and interesting and whatnot. So what do we got here? Yes, debug.trace is fine because we want that. Let's set our Haskell process type. And for this project, we're going to use stack.thci. Cool. Yes, so pseudo values functions. Okay, that's fine. Fix that little suggestion. No, that wasn't right. Why did it suggest something that didn't work? Oh, because I left ID in there. Very good, very good. And some fields of game state not initialized. Random values, I think, are vector that's going to hold them. Yep. And empty? No, it's going to be v.empty probably. Oh no, sorry, it's a pseudo-random afloat, not a v.ft. Okay. Pseudo-random afloats. So this is getting back to our type here. So we actually want empty pseudo-random there. V.empty. Perfect. Still borked. Okay, let's get that fixed as quick as we can. Okay, so the idea with this is that when we start up the game, we should generate our pseudo-random values. And then we have these handy-dandy functions here. Get pseudo-value to get 1, get pseudo-values to get a certain number of them. And it's kind of looking a little bit like a state, monad state kind of thing. Because we have the values we get out, and the next state of the pseudo-random is the second value in this tuple. So I'm thinking maybe we want to start using some of that. However, I'm going to hold off on doing that here, and we'll do that maybe a follow-up change. So let's just get this in a state where we can make it kind of sort of work and get the game working again. And then we'll experiment with that kind of refactor to see if that helps keep the code clean. Okay, so we get pseudo values, looks okay. It's been a while. So first, we kind of use this looks like we use this recursive function to kind of set up some of the state. We're going to accumulate our values in the first list that we pass in. Pseudo is our pseudo-random generator. And count is the number of values we want from it. So accumulate a list of maybe A's that we return here. And then the next state of the pseudo-random A. So we pass that off to cat maybes. And first. Takes all those together, I guess. Okay, so we're not using trace. Let's get rid of that for a second. At least just comment it out until we're done here. Okay, so everything's type checking. Let's see if we can get our asteroid to show up. So when we want to initialize the game state, this is probably the place where we're going to initialize the pseudo-random. So we actually probably don't want the empty pseudo-random here. We want the initialized pseudo-random. So we'll call it generate pseudo-random. That's kind of what I want to be able to write, and to give it a number of things. Now, our pseudo-random is generic. Yeah, it's takes an A as its parameter to pass into the vector. When we get pseudo-random of A, we have to have a show instance, but that's technically it. But we define it as a pseudo-random of float we want, so inference should take care of that. So anyways, we should be able to generate pseudo-random, and we want to write, like, say, like 30 or 40. Let's say 40. 40 is a fine number. It's a number, whatever. And I want to be able to pass that in here. Pseudo random floats. All right. Did I? Oh, no. I mistyped that. There we go. Funny word. I don't type very often. Okay, so we just need to implement generate pseudo-random. What is that going to look like? Generate pseudo-random. So we're going to take an int, that's the number of pseudo-random values to generate, and then we're going to return a pseudo-random of A. Oh, an IO. Sorry, it's going to be an IO. Pseudo-random of A. We'll leave that as a whole. Okay, so that means we're going to need our random module. So let's go add that to package if we haven't already. We picked Merson random pure 64. Okay. Let's look at that API. So it has a pure MT as the pseudo-random generator. So we can create a pure MT generator from word 64 seed, or we can just create a new pure MT. And we can get int 64s, word 64s, word, or double. We can convert the double to a float. Yeah, maybe floating. All right, so okay. So that should be fine. Random double. So let's create a new pure MT and get that going. So system.random.mersen.pure64. Random.mersen pure64. And generate. Pure MT. Okay, so then we have the new pure MT, and then if we want to get a number of these values into a vector. So we can construct data.vector. I wonder if it has some kind of monadic constructor, because we do it like from list. But I wonder if we can do like from like a, like we have monadic indexing, subvectors, construction, singleton, replicate, generate, iterate n, monadic initialization. There we go. Okay, I think this might be what we're in for here. Okay, To execute the monadic action given the number of times and store the results in a vector. Right, so if our monadic action is just to generate using our pure ST thing, or our random number generator, generate a number of random values using our MA here, then we get a vector of A's, and then this M will be IO. In that case, and that should work. So then let's just bind that vector as V's to replicate M. And that takes an integer, the number of times, so that'll be n, some function, and we should get back the vector that we want, and then we return pure pseudo random these with the index initialized to 0. Okay. Then GHC says I found a hole. I need this IO action is an IO of A, something of IOA. And we're going to have to pass in the generator to this. Pure MT, I believe. That. And does that work? Oh. Oh, I just realized I don't have any tunes going. Let me turn on some music. Oh, cool. That's all fun and dandy. Okay. Hang on 1 second. Okay. And we're back. Oh, that's a little better. Okay. So here, our type binding just doesn't believe that this A is the same as this A up here. There's ways we can solve that. The I mean, if we want to keep that, we just need scope type variables, I believe. If I'm not mistaken. That's what we need there. There we go. So with scope, this is kind of like just a weird Haskell thing, I guess. It's not that weird once you know like how it works and stuff and why, but it can be a little bit confusing, I think, if you're pretty new and you're trying to follow like this guideline of like maybe writing out all your type signatures everywhere that you can, even in your where bindings. But for some reason, which I'm not going to get into too deeply here, but if you have like a polymorphic A up here and you just use the implied for all, which when you don't write it, Haskell inserts it for you. And you have an A here and an A and a where clause. Haskell doesn't infer immediately without some help that these two things of this type are the same thing, the same type. So you get like the sign is that you get like an A, and then I can't infer what A1 is. Or if I named it X, it'd be like I can't infer what X1 should be. So scope type variables is the band-aid, so to speak, to fix that, I guess. So we need that here. I think that's the fix for it anyway. I might be totally wrong about that, by the way, so don't listen to me. Learn for yourself. I will also learn on the stream, I'm sure. Excuse me. Okay, so now we just need to provide something that does the thing. So we have the do a random double. Takes our pure MT, gives us back this tuple of a double and another pure MT. Which worries me a little bit. Am I going to get the same, unless... Yeah, okay, this actually does worry me a little bit. I feel like if I just do this, where I do something with random double with G, so I reach into that. Now this whole is a pure MT to A1. No, let's do it this way. Let's just write it out the long way. So if I generate some double, that's not, oh yeah, it's a pure function. It's not an NIO. So let D equal. Okay, so D, I have a tuplet with a double and another pure MT in here. If I don't use that pure MT, it feels like I'm kind of not doing something right. All right, if I just do like pure D, it might not even let me do it. Let's pull it apart then. Okay, so even my scope type variables and that whole spiel I gave is not quite working for me here. It still doesn't know that the A1 I'm trying to generate in this function, gennum, is like gonna be the same A's here for some reason. So I still have the scope type variables in there. What am I doing? Well, it's just not futz with that. Okay. Okay, maybe we do need it. Because what's happening here, right, is I'm giving it this like this kind of polymorphic return value, this like polymorphic A on the right-hand side, right? And that means that as the caller, if I call this generate pseudorandom int, you know, like what am I getting back? What's the type of that thing I'm getting back? It can't just be like, I mean, I can return stuff like that, but at least here, because I'm using the random double function, Haskell's saying, no, this is actually a pseudorandom of double. It's not just any A. It's not just anything. Right, so this is actually a double. Right, and that's fine. Let's not make it super generic. It doesn't need to be. We actually just need floats. So we actually want it to be a float. So we'll need to do some wrapping of D, but this is still not quite right. I think it's still got a bug in it. But I'm just going to kind of lay the groundwork here. We need a function here. So I wanted this to be a function that would take a double to float. There we go. Real to frac, that's the function. Now I suspect because this pure function here is returning the next state and we're kind of ignoring the next state, that if I actually try to use this, we're gonna get like a vector of like the same number. Like it's gonna be a random number, but it's gonna be all like kind of one random number sort of thing. All right, let's run that. Why it's not responding at all to anything? Huh. That's very unexpected. What's happening here? Oh, do. Did I change something with Well, let's look at generate pseudo floats first. So I'm gonna get f's Generate pseudo floats of like 20. Yeah, this is what I expected. So 0.3971195 is the number that we got. And because we didn't feed this back in, because that's how Mersenne twisters work, we're not getting what we want. So how are we going to structure this so that we use that new state of pure empty? I suppose instead of trying to use v replicate m, we could generate our own list and just construct from list, the vector from list. And we'll just do this recursively. Like this, say let f's equal go. Our accumulator will be the first argument, our generator will be the second, and the number of times we want to recur will be our final argument. Or no, we'll make n the first argument. And then our accumulator, and then our generator. And then these just becomes v from list, f's, and there. So go of 0 just means we return our accumulator. We're done recurring. Otherwise, some n more things to generate, our accumulated numbers and our generator. And then basically we want to call go again with n minus 1. To decrement it, we want to accumulate the real to frac of the random double, something of the random double function from the generator we got. No, almost. I'm going to bind those out. Double and next gen. Okay. This becomes that. The next accumulated onto there, and then G, next state of G becomes next gen. We might need to put this, and there comes off. No, real to frac of D, sorry. Bear. We don't need those. Shadowing, right? I'll use a more descriptive name at the top level there. And that should be good. Okay. So if we try to generate this. There we go. So now we actually have some random numbers. That's much better. Okay, and then if we try to get pseudo values, let's just try that quickly. Let's get one pseudo value. It takes our pseudo random f's. And that's right. So it just gets the first one. Right, it increments the index to 1 in our next state. All right, so similar to the API for the MRSA and Twister, right? We get our random and our next f's. All right, and if we tried to get the pseudo random again off the next f's, then we get the next pseudo random number, and the next index should be 2. All right, that looks about 1916613. Or sorry, 0.917. Yeah, and our index is 2. So that looks like it's working just fine. And if we tried to get pseudo values, say 3, we should get 3 values. If we use nextfs starting at index 1, right? So 0.917 or not 917, 191, 1991, 917, 9166. Yeah, so that looks about right there. 991983. So that's kind of how our pseudorandoms will work for generating our asteroids. Okay, so let's clear up our warnings here. Although you're not reporting it in the editor, so we're going to have to go here. Redundant constraint show a and get pseudo value. I don't really care the export lists. Warning, that's fine. Okay. Okay, so let's commit that. I don't think we actually need the scope type variables because we're not really using it. Okay, just this and P64. Oh, I left the trace debug commented out in there. Let's get that. Oh, let's go. Okay, so we're moving it. That's right. Yeah. And generate pseudo floats. Okay. Can we initialize the game? We're going to generate 40 of them. That'll be good. Okay. Yes, this looks good. So let's commit that. Generated pseudo random to initialize game state. To init game state. Yeah, there you go. It's not super perfect, but it's great. It's good. It's good enough for this little game. Okay, So we added it to the init game state. Now to create our points for the asteroids themselves. Although, I'm a little bit concerned with the game actually not working at the moment. Maybe we should fix that first. I did do some updates on this dev environment over the holidays, so maybe that's what's causing this. Maybe my versions of libstl are out of date. I don't need the paths so much. I just need to know what version's installed, if maybe I got it on the wrong one. We get to rendering, it's just not picking up on any inputs for some reason. Into the game state, and then we start the loop. Poll events. Just a quick test that we're actually hitting the loop. Okay, we are. I don't think it's getting anything. Although it's kind of hard to tell with it scrolling by so fast. So maybe we should just get it to pause here. All right, what's the read user input is usually a easy, cheap one to read line from user. Hello. Oh man, this book is, I don't know if it's aged very well. A little bit, it's get stirring or something like that. Get Sterling. Get line. Yeah, okay. Get line. So we'll just wait for user input before we continue by using this little trick. Okay. So window shown, that we expect that. Time exposed. This is all like the very initial events that get fired off as soon as we start up. Okay, that's going to be harder to get it to stop at just a like couple times through. Pause that. Um, What can we do? We could stop at, we could check when ticks is over a certain amount. Give us enough time to get there. Hopefully that's enough. Maybe 10,000. And that won't compile because of when. Oh, parse error. Fun times. Not scope, and that's from control.monad. Keep pressing that down. Hopefully that triggers at some point. Maybe 10,000 was too much. Let's make it go real quick just to make sure that it actually works. Oh, let's print out get ticks. uh, all right, here we go. Chat. I gotta check on you. I haven't checked on you in a while. Shawnee, welcome to the stream. A promotion to my channel. All right. Very good. I'm not really into the promotions for my channel, but thanks, Shawnee. Any hoozle. Okay, now, so we should be hitting it any second now. There we go. No events. Let's try that one more time. I'm going to be a little bit more aggressive. Let's hold down some buttons and press a bunch. Nothing. Okay. I think the input handling is borked for some reason. It might be that my version of SDL is not up to date. Or I updated my local systems SDL here beyond that, which is supported by the Haskell library we're using here, which is my bad. Okay, so let's get rid of all that stuff. We're going to have to look at what version of the library we have. SDL2. We're going to have to look in the stack. Resolver. 1931. SDL2. So it might want to SDL 2.06. Okay. Version do I have? SDL 2.0.2. I think it's 2004. This is what I'm running here. Ugh, useless. Okay, it's 2.10. So, is there a newer one? Maybe Hackage. 2.06 plus. So it's at 2.5.4. Stackage is 2.5.4. So it should be up to date. Huh. Yeah. Maybe it is my bad. What's going on? I know this commit was good. check out that commit. No, 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 I don't want to revert. Abort, abort, abort. No, I just want to check this one out. Um, okay, bills. That's good. No, still not taking anything input here for some reason. Ugh, how frustrating. Yeah, we haven't... Yeah, it must be something on my system. It's gotta be. It's gotta be. Do, 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 do. Let's take it the most recent tag. So let's try it from checking out from the tag in stack.yaml. We can put extra deps here. Now we want SDL2 to be from the git to the checkout of this thing. Blah, 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 and git there. But I want it to be this particular tag. There we go. Oh, okay. I put commit on the other line here. This commit and the repo. Okay. See if that fixes things. Otherwise, I can try downgrading my libSDL. And I'm sure at some point, somebody who understands Nix is going to come in and tell me why, and ask, why am I not using Nix? Betcha. That's because I just don't know Nix. I haven't taken the time to learn it, and it's a whole thing. Also, my poor hard drive space. I'm kidding. I'm kidding. Okay, so hopefully that works. It's kind of boring sitting here looking for compiling and watching compiling stuff scroll by. So, what can we do? Let's look at the state of the Haskell verse, and as far as Reddit's concerned. Cool. Haskell project. Like to see it. A CSS parser. Cool. You know, actually, one of the things I've been meaning to do is to do a code review of that Steam game that came out not too long ago that was written in Haskell. Might give us some ideas for this project. So the project is based on Dillo web browser. It's an existing project with C and C++ code base being slowly rewritten by this person in Haskell. Ooh, cool. The biggest part written in Haskell is responsible for parsing and matching of CSS. Spare time project. Not expecting a whole lot, just that you're having fun. Okay, cool. So let's check it out. Show me the HS files. Cool. CSS selectors. This CSS always, modern CSS, I should say. Not the stuff that I used when I was a young man. Seems really, really complicated. Oh no, they left a debug.trace in. Oops. All right. 90 is the full number of HTML4 elements. Okay, cool. So a compound selector is something that has a pseudo class, or a list of them, a selector ID, a list of selector classes, and a tag name. Cool. All right, looks like we're done compiling. Let's see if this actually works now. It does. Okay, we're back. So it was me. I updated the SDL library. It doesn't work with the stackage one. Sorry, stackage. That's frustrating. Woohoo! But we're shooting bullets and running around now. So this is what the game looks like. This is what I wanted to start with on the stream tonight. Woohoo! Yeah. So CSS selectors implemented. Very cool. You know, it might be a pretty fun to do a browser project in Haskell for funsies. And maybe not like an HTML like HTTP web browser, but I'm thinking like I think it's called Crystal. Is it Crystal? Crystal. Oh, no. There's this alternate like kind of like Gopher like system. Gemini. That's it. Gemini? I don't know. I think it was Gemini. Yeah. So like something really simple. And Gemini is like kind of this super simple thing. I don't know a whole lot about it. I've just seen people mention it and like a couple little projects that are like, I wrote this thing for Gemini. Seems kind of neat. You know, if you're kind of tired of, you know, the modern web and want to get back to that kind of like do-it-yourself DIY, low-tech kind of vibe and experience, could be pretty fun. Do something like that in Haskell. Be a lot simpler than a full HTML browser. Not that that's not unachievable with Haskell, of course, but anyways, we got our game back, so let's get back to that. Thank you, Haskell community, for the awesome projects and making cool stuff. Okay, so that's the fix we need for our main branch. I'm just going to discard these changes. Check out master. So when apply this change, we'll update SDL2 dependency to latest tag. I should be specific. 2.0, 2.5.4. Oh. Cool. My bad. I should declare a dev environment for that because eventually we're going to want to, when we want to deploy a game, you know, built using SDL2, we're going to have to ship the library alongside our binary. Because it's a shared library. And we'll have to be very specific about which one. And maybe not rely on the system's SDL2. We should probably just ship our own with it. And not depend on it dynamically. Any hoozle. So that's that. Where were we? Yes, we were at generating our asteroids. So here we are. We're going to add some asteroids. Okay. So did I have a function for that kind of started somewhere? Update loop. No. Okay. Let's move the pseudo random stuff out to another module. Get it out of game. I'm just going to grab it all this handy dandy stuff. I'm going to pop it in here. We're going to get the imports we need. We need record wildcards. Okay, and the type there. And then we have to import. And data.byfunctor. No capital F in there. Okay, now apparently these become redundant in the main module here. As well as data.byfunctor and data.maybe. Super. Okay. Just make a commit out of that quickly. Not applied. This change will move pseudo random to asteroids random. Okay, and now let's do our asteroid generation stuff. So let's write generate asteroid. Well, actually, let's create a data structure for our asteroids first. So we'll have asteroid points. It'll be, say, a list of float. And an asteroid position. A V2 afloat. Okay. So list of points, a position. Let's call generate asteroid. Takes a pseudo random. I kind of actually want to remove the pseudo random A, like the polymorphic parameter. We're only using it for floats here in our game. We should probably just not make it so generic. Maybe. It's kind of annoying me at this moment, right at this very second. I don't know if I'm going to use pseudo randoms for anything else in this game other than floats. Anyways, might be something I want to change. So generate asteroid takes a pseudo random float, and then we return an asteroid. Actually, not just any old asteroid. We're going to return an asteroid and the next pseudo random float. So all we have to do to get our asteroid here right, is generate pseudo floats. Get pseudo floats, pseudo values. So we want our asteroids with 6 points. Just to start, see how it looks. And we need a position for it as well. Yeah, we need to bind out some things. Yeah, so we're going to bind out the points, next gen, And we're going to get pseudo values. Let's say 6 points, we're saying. And that takes the gen. And then we need 2 points for our V2. Okay. So now, we should be able to construct an asteroid. Well, since we know the size of the size of the list of pseudo points is going to return, I'm just going to pattern match that out here. Asteroid, and we get our points, and then our V2, X and Y, position, and final gen is what we return. And so we're not using next gen, that needs to be used here. I'm going to get a warning for that, because the pattern match is not exhaustive. But I can turn that off if I really want to, I think, with a comment. Selectively, just because I know that that's kind of a thing. Okay, so we have generate asteroid. Why don't we, and then let's draw an asteroid. And then we can get an asteroid up on the screen as quickly as we can. It's going to take the STL renderer, the asteroid we want to render, and return IO nothing. So we're just going to affect the screen here. I'm going to bring those out with a wild record pattern. Okay, and so we basically just have to run around from point to point, drawing lines between them, and then close the loop. Sort of like how we do with the ship points. Now, we're getting just completely rando points here, so it's just going to go blah, blah, blah. So when we generate the, that's a technical term, by the way, blah, blah. When we generate the floating points that we get from the pseudo-random, we're going to have to, like, adjust them, right? Because we want not just any pseudo-random flow, we want something that's, like, within the space of our screen. And we're going to constrain somewhat those random points that we get around the center point of the asteroid, basically. So we have some transformation to do on those numbers that we get back from that first. So I expect this is going to look a little weird, but I'm going to basically assume that we can go around from point to point to point in kind of a circle, however randomly distributed they are, and we'll just try and close to the last one. So, render asteroid, and then we'll fix up the point clustering in generate asteroid after we get something going to the screen. Right. So, let's see, how are we going to do this? We have the list of points, and we want to step through them. We want to cycle through them 2 by 2. Because each point in the space is going to be, so we kind of need to generate 6 uneven number because we need pairs. To turn into positions for the draws stuff. So let's see. Points. Something with asteroid points. Oh, maybe we should do that transformation here in the data structure so we don't have to do that here. That would be silly. Getting ahead of myself. So yeah, let's do asteroid points as a list of V2 floats. That makes more sense. All right, so when we get the list of random six random points, I call it like fix asteroid points. Or maybe muck asteroid points. And this will be a function that will take our list of float and go to the list of V2 float. And anticipating how we're going to fix this later, we'll have another parameter that will be like an initial V2 to center these points around as well. So when we're generating the asteroid, we get like just six of these random numbers out of our generator. And then we kind of want to like bring them around a certain point, and we can do all that transformation here and kind of keep all that here. But I'm just gonna do this mapping for now. So then we can change this here to be mock asteroid points. Cool. So this function, get rid of that. This function here, list of floats, the list of V2 floats. We have to do something with this input list first. And I think we have a function in data.list for grouping stuff. No. We might have to write our own. So we need like a pairs function, pairs of elements, something like this. So what is pairs? It's going to be a list of, or it's going to be a function. Is that even necessary? I don't know if that's even really necessary. If we had that though, this function becomes a pair of float float to v2 float, or because this would just be v2. Yeah, it seems a little bit odd. Yeah, let's leave it in. If we had such a function, then we should be able to map something onto it to get our v2 floats. What's that going to be? It's going to be a function from tuple of float to float to v2 float. Supposed to be float to float like this. Float float to v2 float. Okay, I'm assuming we can write some term that replaces those undefined. That should all work. Now, to write pairs, we're going to need something with the tails. Or should we pattern match out first? X's. No. Data list. So tails. This one. Ciao. Right, so we have the tails of 1, 2, 3, 4. Let's import data.list. All right, we get a list of these sublists. And what if we do cons out ahead of this with the tails of the rest? No. Take the tail of that, 2, 3, 4. Yeah, so if we have x and then 2, 3, 4, that means we have 1 and this. And we want to take the pair of 1, 2, the pair of 1, 3, and the pair of 1, 4. And then recur again. Cons the recursion until we run out. All right, so we take the pair. Some list concatenated with the natural recursion of pairs on x's. Wow, hold your horses. So then from here, we want to take x, y, for y. It's going to be tails of x's. So we have to do something with y, I think. Yeah, so it's list of float. We want just the head of it, except head is partial. And that means that if we try to get it, it can fail on the empty list. So if we can guarantee that y is never the empty list, then we could use head here. We could guard this, maybe. Not the most efficient way, but such that y is not equal to the empty list. Y is not empty. That's probably the better way of saying it. Such that the length of y is greater than 0. Not null y. There you go. Okay. And then this to v2 is pretty straightforward. X, y is just v2, x, and y. I'll probably even just uncurry v2. Cool. Let's generate an asteroid. Well, we're going to need a pseudorandom first. Let's generate 20 pseudorandom floats. Generate asteroid. We just have to get the P. Asteroid points. 1, 2, 3, 4, 5, 6. Well, actually, there's more points than I was thinking we would have. My implementation of pairs is probably bad. Let me bring pairs up. Yes, okay. Well, that's not quite right, is it? Yeah, I'm thinking that I think I was implementing the wrong function, for one. This is not the pairs function I was thinking of. But I got on the wrong train of thought with it. Oh, how embarrassing. We just want to chunk this literally into 2 groups of 2. We could, like, if if the list is an odd number, we could just drop the odd number. Oh, and where we just have one element. That's more what I was thinking. We get 5. We should still get just 1, 2, 3, and 4. And if we have just 1, we get the empty lists. 1, 2, we get that. That's good. Yeah. Yeah, I think I was implementing combinations, but yeah. In fact, I don't think this really matters. So we'll move this into a little helper module. Asteroids, list utils, or just list.hs. I'll just import here. Yeah, then we don't need tails anymore. That's redundant. Okay, the other warnings I'm not too worried about at the moment. Okay, cool. So let's get our P again, and now let's try our generate asteroid. There we go. So we should have 3 points. 1, 2, 3. Great. And then position, and then our pseudo-random state should be at position index 8, right? Because we asked for 6 numbers plus 2, so 8 numbers total, yeah. So there you go. Cool. Okay. So there's our asteroids. Now we can render one. I'm going to save this function for a second. I'm just going to check this in. Pseudo asteroid generator. Okay, now renderer. What are we doing for time? We're a little over time today. Okay. We're going to have to get to rendering another time. Next week. So welcome back. Thanks again for tuning in. I do these streams once a week. Around 10 after 8 on the Eastern, I think we're on the daylight time zone now. The Eastern time zone. Here on Twitch. You can follow me, of course, here. Just smash the follow or whatever button. Follows are great. If you're watching on YouTube, you know what to do there to get all the updates. So when you follow here, you'll get notifications and all that stuff if you want them. So happy hacking out there. Enjoy the Haskells. Check out declarative.tv, of course. There are other great streamers who are doing stuff in all kinds of cool programming languages all the time. And we also have a Discord channel for this channel here that you can hang out at and tell me about your projects, discuss what we've been building here on the stream as well, and just have a fun time talking about functional programming. So may all your types always check, may your monads always be free, and I will see you next week. Take care.